So we are going to do lesson 6.3, which is factor by special products. Okay, and the first one that we're going to see or study is the perfect square trinomials, right? So when we square a binomial, we end up with what we call a perfect square trinomial. So when we square a binomial, we end up with what we call perfect square trinomial. So what do perfect square trinomials look like? You have seen them, but you have not, we have not paid any attention to them. So the perfect square trinomials is a plus b squared. Like we said, when we square a binomial, we end up with a perfect square trinomial. This is equal to a squared plus 2 times ab plus b squared. And let's do an example. We have x plus 1 squared. So we know it's going to be what? X squared plus 2 times x times 1, which is x, plus 1 squared. And we know that if we had a negative a minus b squared, so we're going to get a squared minus 2ab plus b squared. Okay? And here's the other example. 3x squared. So it's going to be first one squared minus 2 times 3 times x is going to be 6x plus this one squared is going to be 9. We know that a is x and b is negative 3. All right. Let me just show you a very common error is that we said a plus b squared, and what we do is we apply the power. So we said that this is equal to a squared plus b squared, and that's not true. Okay, because a plus b squared is not the same as a squared plus b squared. Be careful. Right here, a term is missing in the middle. But something even more important than that, we never distribute powers. We never distribute powers, okay? Don't forget that. So that's not how the distributive property of multiplication, that's not how the distributive property of multiplication over addition works. Now, here's another example. Let me write this down here. Remember that it's not how the distributive property of multiplication and over addition works. Don't forget that. Now, I have another example here. It says factor x squared plus 12x plus 36. Okay? If we use the sum and the product method that we just learned, we get what? X plus 6 and x plus 6. Two numbers, when you multiply, you get 36. When you add them, you get 12. And this is equal to x plus 6 squared, because I have two of those. This is a perfect square trinomial. Perfect square trinomial. Perfect square trinomial, right? So how do we recognize a perfect square trinomial? How do we do that? So how can we recognize perfect square trinomials? So first, this is what we could do first. The first term is a square. The first term is a square. So x is equal to x squared. Now, the second term, the last term, sorry, is a square. Let's check. 36. So it's 6 squared or negative 6 squared. Now, the middle term, is what? Is twice the product of the first term, and the last term is twice the product of the first term and the last term. So, for example, we have what? 12x, right? 12x is equal to 2 twice what? The product of what? Of the first one, which is x, and the second one, and the last one, which is 6. Last. The first one, and the last one. Okay, now let's practice it. So we have it's asking me, are these perfect square trinomials? And if they are, if so, we need to factor in, okay? All right, so let's do the first one. The first one says x squared minus 10x plus 25, right? So we have, let me get this here. So let's do the first one. Let's see if it's a perfect square. The first term needs to be a square. It is, right? The middle one needs to be what? What do we say? 2 times? Oh, it's the last. Okay, sorry. But the middle term is twice the product of the first term and the last one. I believe I need to do the middle one, but the last one. I need to do that. The last term, what is the last term? Is 5. So the middle one is going to be 2 times what I have in between parentheses, which is x and 5. So right here we could add and that gives us what? 10x. So this one, it is a perfect square. So this is going to be equal to what? X minus 5 squared. Okay? Now let's do another one. We have 4a squared plus 12a plus 9. So we have first term is going to be 2a squared, right? Last term is going to be 3 squared. Now the middle term is going to be 2 times what? 2a times 3. 2 times 2 is 4. 4 times 3 is 12a. So yes, it is a perfect square trinomial. And it's going to be equal to what? To a plus 3 squared. I'm sorry, 2a. Now, let's do another one. 2, let's do 3, 4x squared now. So the first term, hold on. We could factor the y to the third power out of here. So it's going to be 4x squared minus 4x plus 1. Now we can do it. First term is going to be 2x squared. Last term is going to be 1 squared. And the middle term is going to be 2 times what? 2x, which is going to be 4x. And that's what it is. So, yes, it's a perfect square trinomial. So we're going to factor it. Don't forget this. So it's going to be what? 2x minus 1 squared. Okay? Now let's do number 4. 81x squared plus 36xy plus 4y squared. Now this one, let's do the same. First term is what? 9x, right? The last term is what? 2y squared. And the middle term is 2 times 9x times 2y. 9 times 2, 18. 18 times 2, 36xy. So, yes, it is a perfect square trinomial. And the first term is going to be 9x. And the second one is going to be 2y. And that's going to be a square. Right? And I'm going to do one more here. All right? This one is 3x squared minus 21x plus factor out the 3. This is 7 and this is 16. There we go. So let's do. First term is going to be x squared. Last term is going to be 4 squared. Right? And the middle term is going to be 2 times x and 4. 2 times 4 is 8x. And I have what? 7x. So no, not a perfect square trinomial. Okay? Finally, we found one that is not. Now, let's go into the second. We were going to study the perfect squares trinomials. We were going to study the difference of two squares. That's the next one. Difference of two squares. Difference of two squares. So let's do it. We have to find, let's do this one first. Find the product of x plus 1 and x minus 1 by distributing. Okay, so let's do it. So we have x plus 1 times x minus 1, right? So we're going to distribute this. So we do x times x is x. We could do it like this first. And this one would be what? Now, the next one is going to be that's what we do. So what do I get from here? X squared. From here, I get x, negative x, plus x minus 1. If I combine these two, I get x squared minus 1. Now, how about x plus 2 times x minus 2? So let's do it. X plus 2 and x minus 2. X times x, we have this one times this one. X times negative 2 plus 2 times x plus 2 times negative 2. So from here I get x squared, 2x plus negative 2x plus 2x minus 4. So what I have is x squared minus 4. What did you guys notice? Did you see that the middle term made a 0? You guys see that? And why did this happen? Because the multiplication with the middle terms turned out to be opposite. So opposite quantities, what happened? Always add to 0. And we have a special name for binomials that do this. And we call them conjugates. So A minus B is a conjugate of A plus B, and vice versa. And let me, before we start doing exercises, let me write that down. So we have, one thing that we notice is that the middle terms made a what? A 0. That's what they did. The multiplication with the middle terms turn out to be what? Opposites. And we see it here, right? And what do we say about opposites? Opposite quantities always add to zero. Opposite quantities always add to zero. Don't forget that. And we have a name for this type. There is a special name for binomials that do this. And we call them, they are called conjugates. Okay? Let me get my highlighter. That's what they are called. They are conjugates of each other. Okay? So it means like A minus B is what? It's the conjugate of A plus B. And vice versa. They have what? What do they have? They have the same two terms, but opposite signs between them. The same two terms, but what? Opposite signs. Look at that. Between them, all right? Now let's do some exercises. So we have it says factor the following. So the first one is going to be x squared minus 16. So this is what? This is going to be x plus 4 and x minus 4. They look like this one. They don't have a middle term. Now, 25b squared minus 49. Okay, this is gonna be 5b minus 7 and 5b plus 7. Okay? Number 3, 45 minus 20x squared. First, I'm going to create the greatest common factor. I'm gonna factor it out. So this is 9 minus 4x squared. Now we're gonna factor this part. Two x. Okay. Let's do this one. We have x to the 4th power minus 1,000. No, 10,000. Okay. So this is equal to what? X squared to the second power, and this is 100 to the second power, right? So this is equal to what? X squared plus 100 and x squared minus 100. You see that? But we can't do anything here, but we could keep going on this one. We could do what? X minus 10 and x plus 10. Remember, this is a prime polynomial, okay? When we have the plus. So the sum of two squares cannot be factored by using real numbers. And I'm just going to give you right here the sum of two squares cannot be factored by using real numbers. Okay? And now, number 5, x plus 2 squared minus 144. So this is what? This is x plus 2 squared minus 12 squared. So the first one is going to be x plus 2 minus 12. And the other one is going to be x plus 2 plus 12. Right? And if I take this parenthesis out, what do I have? X plus 2 minus 12. And over here is x plus 2 plus 14. So this is equal to x minus 10 and x plus, sorry, this is 12 plus 14. Okay? And the next one and last one is the sum and difference of cubes. So we've done the first one for factoring trinomials. The first one was the perfect square trinomial. And the second one is the difference of two squares. And the last one is the sum the sum and difference of cubes. Okay, so let's do so multiplied. If I have a plus b multiplied a squared plus minus ab plus and the other one will be a minus b. A squared plus AB plus B squared. Notice that here's positive, here's negative, here's positive. Okay? A squared minus B squared. These formulas are known as the sum and difference of cubes. Cubes. Cubes, okay? The sum and difference of cubes. We don't need to memorize this. You just need to be able to recognize and correctly factor it, okay? So, let me give you an example. So we factor, the first one that we have is x to the third power plus 64. Okay, so it's going to be like the first one, right? So it's going to be so a, and this is going to be 4 to the third power. So this is going to be 8 plus 4, x, sorry. So here is going to be x squared minus 4x plus 16, 4 squared. And we just factor it. Now let's do a negative. So the negative is going to be I'm just writing down the formula so I know. So this is going to be p to the third power, and 27 will be what? 3q to the third power. So this one is going to be p minus 3q p squared plus 3 times pq plus 9q squared. Okay? And this one's we gotta do one more step. We have before we start applying the sum and the difference of cubes. So this one we have 125 I'm gonna factor out the q. So it's gonna be 125 minus n to the third power. That's what we have. And this is equal to what? Gotta write this down. 5 to the third power minus n to the third power. Q to the second power is going to be 5 minus n sorry, and we're gonna multiply what? We're gonna have 25 plus 5n plus n squared. And I do have another one. This one is b squared x squared minus 8x squared. We will have to factor the x squared. Okay? So we know it's going to be what? This is 2, right? Oh, but the 8, this is fine. But 2 to the third power will be that. So it's going to be b minus 2. And we're going to do the b squared plus 2b plus 4. I'm just following the formula. That's what I'm doing there, all right? Because what I have here is that's what I have there. So I just do a minus b, a squared plus 2b plus 4. All right? And that's exactly what I did on this one. A, and we did a minus b and a squared plus 2b plus, not plus 4, it's plus b squared. All right?